Hey everyone, welcome back to section 5 of Code in Place. This is your last section. That's crazy. We've gone over the last 5 weeks so quickly. And I hope you've realized beyond all else, Code in Place is about programming, sure, but it's also kind of about the joy of learning something new with a ton of different people. And that's really what we're going to try to celebrate in today's section. Of course, we are going to talk about programming. We are going to think about everything we have learned as well as what we're learning this week. But even more importantly than that, we're just going to spend some time in our sections thinking about exactly how the sorts of things that we've learned can be used to solve incredible problems, but can also just be used to introduce a little joy into people's lives. So in fact, today's first section problem is a game. And because games are kind of a little lame to demo by yourselves, we actually have a very special guest with us today. Patricia from the teaching team is joining us. Patricia, want to say hi?
Yes, hi everyone. I'm so happy to be here, and yeah, I'm so excited for this section.
Fantastic. So without further ado, Patricia, want to play a game?
Yes, let's do it.
All right, so let's get started on the game. This is a game called Heads Up. You may have actually played this game on your phone with your friends in person, but unfortunately, some of those things might not be possible right now. So we're actually in section today going to build a remote version of that game. A game is kind of a lame thing to demo without a friend. So like I said, I've got Patricia here, and Patricia is going to play this game with me. The way this game essentially works is that we start off with a list of words. This is a list of Code in Place related words. Hopefully, at least some of them seem familiar to you. Patricia and I have made sure that we at least know what they are. And the way this game is going to work is that we're going to basically be running a program that gives us random words from this list, one after the other. So I first get the word ed, and if I press enter, I get section leader, and enter again, and I get simple image, and so on and so forth. Now, the idea over here is that as these words are coming up, my eyes are actually going to be covered. And what we're going to need to do is have Patricia describe the word to me so that I can guess it. Now, we'll do that a couple times, maybe 5 times each, and see how many we get correct. So the pressure is really on us. I promise we haven't practiced this in advance or anything like that. So with that said, Patricia, you ready to get started?
Yes, I'm ready.
Fantastic. So how about I go first with the guessing, and then it'll be your time to share. Okay, so let me go ahead and run this program first. And I'm going to take my glasses off, cover my eyes. I'll also look in the other direction so that you know I'm not cheating. Okay.
Sounds good. Okay, so you can look at this is like something where if you don't know what something is, you can go to this as a blank. Another way to describe it is when you pass in a parameter, you can either pass it by value.
Oh, a reference.
Yes.
Oh, I totally forgot that now. I lost the enter key. Okay.
Okay, so basically when you have a function and you want to do something with it and you want to maybe pass the thing the function does back to the main program.
Return value?
Yes. So anything that's like a word or a name will get stored in this type of value.
A
So
string?
yes.
I should know that after last week's lecture on it.
So this can store a collection of things. So a bunch of names or a bunch of numbers. You can separate them with commas.
A list, a file?
Yeah, a list. Yeah.
Okay.
Oh, this was the same thing. I'll describe it again.
Same word again? Okay, fair enough. Let's try one more.
So when you start your assignment, it's not going to be completely blank. It's going to have like the name of functions in it. So that this is like what that's called. Like
scaffold, the starter code?
Yes, starter code.
Fantastic. Okay, cool. I'm nervous to keep on going and break my streak. So your turn now.
All right. Okay.
All right. Okay. Interesting that we're seeing the word lists twice. That might give something away to y'all, but that's okay. You ready for this, Patricia?
Yes. I'm kind of nervous, but yeah.
So this is if I want a bunch of consecutive numbers starting at 0 and going up to some other number, I would call this function.
A bunch of.
I also might use it in a for loop if I want to do something a specific number.
Oh, range?
Yes, nice. All right. One of the instructors of Code in Place, they grew up in Kenya. They just had a daughter.
Chris Beach.
Fantastic. Okay, so this is, you described a reference to me a little earlier on. One of the metaphors we might use for a reference is this thing. It's also how we might find a website on the internet.
URL?
Yes. Okay, this is a number that could represent a decimal as well as like a whole number.
Float.
Nice. This is another one of the instructors of Code in Place. I think you may have taken 106A with them. I don't remember, but they were the first person I TA'd with. They are very famous for teaching 106A.
Nick Perlante?
Nope, but good try. One of the teachers of yeah, Neuron. Nice.
Oh, okay.
Let's try one more. Okay, so this is something you'd use if you want to repeat code, but know how many times you want to repeat it.
For loop.
Okay, great. Okay, this was reference, which you described to me, so we'll move on. Okay, this is a library we would use to represent like pictures and pixels and so on and so forth.
Simple image.
Fantastic, and let's call it there while we're both ahead.
Okay.
Nice job. Cool, so hopefully you've seen both that this game worked, as well as the fact that Patricia and I at least kind of know what we're talking about in this class. So with that, we're not going to dive into some of the theory behind the programming that allows a program like this to exist, and then jump into actually implementing it. But with that, Patricia, we'll let you go. Thanks so much for joining us today.
Thank you. This was so fun.
All right, we'll see you later. All right, now you're stuck with me, but I'm really excited to get started on today's problem. It's a lot of fun to play it, both in your sections, but also just friends and family. I put together a few other files just with inside jokes and stories for both my friends and my family. I played it with them, and I just had a really great time. It's a really great example of how writing a program that, as we'll see, is not a particularly long program, can really bring a lot of joy to our lives, and that's something that's really exciting. After that problem, we'll also talk a little bit about how these sorts of tools that we're going to be using can be used to solve even more important problems and give us insights into really important issues. But let's get started first with a review of some of the things we're going to be talking about today. All right, let's get started by talking about lists. Now, lists are incredibly exciting things. There's the first time that we're able to store more than one value in a specific variable. So for example, over here, what I've done is I've defined a list called LST, and inside that list, I stored two elements. The first element is the string Carol, and the second element is the string Simba. So up until we learned about lists, one of the restrictions we faced is that variables could only have a single value. They could be a float, or a string, or an integer, or an image, or a pixel, or any number of other things, but they could only be one value. A list allows us to store any number of values in a particular variable box without needing to create a new variable for every single value. So that's super helpful. But let's talk a little bit about what we can do with lists. Before we get there, I want to quickly mention how exactly lists are stored in our computer's memory. And the way that basically works is by storing what we call references in our computer's memory. So really what happens under the hood is LST, the variable box, still only contains one thing, but that thing is the location of our list somewhere else in the computer. Now that's really helpful because what it allows us to do in our head is think of LST kind of as just like a luggage tag for this list, or a reference telling us where to find this list in our computer. So that's helpful because now whenever we start calling methods or doing things to this list, what we're going to be able to do is follow this arrow and modify the list in place. So let me show you how that works. I might, for example, want to append to this list, which means insert something at the very end of the list. So over here, for example, I want to insert the string Python. Well, I call the .append function, and what happens under the hood is I follow the arrow from LST over here to the list itself, and then insert Python at the very end of that list. That's a really helpful thing to be able to do, because it means not only can we store multiple values inside a variable, we can change what those values are. Let me show you one other thing we can do with lists. We can grab elements at particular indices from lists. So what exactly does that mean? It means that, for example, over here, we can assign each element of this list a number. Those numbers are referred to as indices, and they start from 0. So Carol over here is the 0th element of this list. Simba is the first element of this list, and Python is the second element of this list. Now, that's really important because it means now when we say something like S equals LST at 1, what we can do is find the element at index 1 of this list and then store it in a variable. So I'm storing it over here in a variable called S, meaning that in our computer's memory, we now have S, which is a reference to the string Simba in our computer's memory. Okay, great. Now that that's out of the way, let's talk about something else we could do. So far, what we've done is we've added stuff to a list and we've taken stuff out of a list. But what if I want to change what's in a list? For example, what if I wanted to change what the first or the 0th element in this list was? What I could do is say something like this. LST at 0 equals the string Meron. And what that's going to do is it's going to take whatever's on the right side over here and put it in the left side. So if you take a look at the list over here, you'll notice that the element at index 0, that is Carol, turns into the string Meron. So that's what a string like this does. It allows us to reassign what's in a particular position in the list. Okay, now that that's out of the way, let's talk about something else. Let's, for example, talk about what we do if we try to insert into an index that doesn't exist in the list. So I said I wanted to set the 3rd element in this list to the string programming. But if you take a look at our actual list over here, there isn't an element at index 3. The element at index 2 is the very last one we have. So really what happens when we try to insert into a list that at a position that doesn't yet exist is we're kind of like Wile E. Coyote just falling off a cliff over here. We've just gone too far and Python's going to complain. The way it's going to complain is by giving us what we call an index error, which basically is saying, hey, you try to get or set a value at an index that isn't valid for this list. So that's, kind of a heartbreaking moment, but most of the time it's just because we've tried to go too far beyond the ends of the list, and that's something to keep in mind. Okay, with that out of the way, let's talk about a few other things you can do with a list. You can, for example, get the length of a list, and you can do that by calling the len function and passing the list in there. What that's going to do is that's going to return the number of elements in that list. So in this case, there's 0, 1, 2, or when we count in normal numbers, 1, 2, 3 elements in this list. And so we store 3 over there. So notice that I actually fell into a trap a little earlier on. I started counting from 0. But when we're talking about the length of the list, all we really care about is how many elements there are in the list, which is 3. Okay, cool. With that out of the way, now let's talk about one really important thing we can do with the list, and that's iterate over the elements in the list. For example, over here, what I have is a for loop that iterates over the range of possible indices in the list. So for example, in this list over here, num_elem was 3, meaning the length of the list was 3, and the indices in that list were 0, 1, and 2, meaning that this range function over here would give us the range from 0 to 3, not including 3. That is the numbers 0, 1, and 2, which correspond to indices in the list. So what this is basically doing is each time we go through the for loop, we're going to get back a new index in the list and then print the element at that index. That's what's happening on this line over here. But even nicer than that is the ability to do exactly that without actually having to worry about indices. Lists support a kind of notation called for each loops. The way that works is just by directly looking at each element in the list and printing that element out. So importantly, both of these loops actually do exactly the same thing. They both iterate over the lists in the same order. What is different about them, though, is the fact that this loop over here gives us access to the indices in the list, whereas this loop over here just gives us access to the elements. As you're thinking about how you might be writing lists problems, definitely think about whether or not you need indices. If you don't, you can probably get away with using this cleaner looking loop over here. So with that in mind, we've got lists out of the way. Now, of course, there's a lot more we can do with lists. I definitely suggest checking out the lists lesson if you're still shaky on some of those other things. But I want to build a working understanding of what they can be used for and how we might apply them to the Heads Up program. All right, let's get started by looking at a program that uses lists and making sure we're all on the same page about how exactly we use concepts like appending and indexing into lists to understand how we might be able to use them in a program like the Heads Up program later on. So let's start by looking at line 6 of this program, in which we define a list called names with 4 strings inside it. I think it's a really good idea as we look at programs like this to start drawing out what our variables look like. So let's go ahead and do that here. So we have a variable called names, which is a reference to a list in our memory. The way I kind of like drawing that out, like I did in slides, is have a box with an arrow pointing at the list we care about. So in this case, that list contains Julie, Maron, Simba, and Aisha. And I think it's also helpful whenever you're drawing out lists like this, you just keep a note of what the indices in our lists are. So Julie is at index 0, Maron at index 1, Simba at index 2, and Aisha at index 3. The next thing that happens in our program on line 7 is that we append names to, we append the string Carol to names, meaning that what we're going to do is we're going to go from the names reference and follow the arrow to the actual list object to which we're going to append the string Carol. So let's go ahead and do that. Carol. And mark that as index number 4. Awesome, super helpful. Let's now talk about what happens in this next sequence over here. For value and names, print value. As I showed you in the slides, what this is going to do is it's going to iterate over the elements of this list in exactly the order that they show up in. That is, in the order of their indices. Meaning that what we're going to see is we're going to print Julie, and then Maron, and then Simba, and then Aisha, and then Carol. So let's go ahead and do that. Let's quickly note down for ourselves so that we can make sure we got it right later on, that the way we're going to print stuff out is we're first going to print Julie, and then Maron, and then Simba, and then Aisha, and then Carol. Great. Once we've got that, now we move to the next segment of this program. Take a second to pause the video now and think about exactly what might be going on over here. And once you've thought about that, resume the video and we'll keep going. So what we've got here is a line of code that says max index equals len names minus 1. Let's go ahead and write that down. Let's just do it over here. Max index is equal to len names minus 1. So let's track through this together. What we first need to do is figure out what len names would be and subtract 1 from it. So len names is the number of elements in the list. That is 1, 2, 3, 4, and 5. And then once we subtract 1 from that, we get 4. So just to quickly write that down for ourselves, len names is 4, meaning that max index is going to be equal to, oh, I'm sorry, len names is 5. And so max index is going to equal 4. It's easy to get mixed up with the zeros and ones. But okay, so we now know that max index is 4. This is interesting because it also corresponds to the maximum index in our list. It's almost like that was intentional or something. Once that's done, what we're going to do is we're going to select a random number between 0 and the max index. That is 0 and 4. So what this line of code is doing, line 17, is saying, give me back a random index in this list. What we then do after that is we figure out the correct answer as the answer that is at this index over here. So what that basically means is if we pick, say, the number 2 as our random index, correct answer will be the string at index 2 or Simba. If we picked 0 as our random number, then we'd get Julie back. If we picked 4 as our random number, we'd get Carol back. So what happens down here then is that we're basically then quizzed on what the name at that particular index is going to be. So we ask what's at that index. We then, if the answer the user gives is the correct answer, we print a message of affirmation. Otherwise, we say what the correct answer was. So let's go ahead and run this program and actually test ourselves on how this might be going. So we're going to go ahead and do this. Do Python 3 index game.py. And awesome. First of all, notice that we printed Julie, Maron, Simba, and Aisha in exactly the same order that we did over here. Julie, Maran, Simba, Aisha, and Carol. So we're off to a good start. And now it asks us who's at index 1 of this string. Now, index 1 in the string, if we take a look at our whiteboard again, is the string Maran. So what we're going to do is type Maran and press enter. And great, we got it right. Let's try again. This time we're asked who's at index 3. And if we look at our diagram over here, the name at index 3 is Aisha. So let's go ahead and type that, Aisha. Great. Let's try getting it wrong once now, just to see that the program does in fact say that we're wrong. So who's in index 0? Well, we know the correct answer is Julie. So Julie would be what I wanted to say if I said good job, but let's say instead Brum or something like that, an answer which isn't correct. And so we're told that the correct answer was Julie, meaning that this variable over here, correct answer, is the element at index 0, and so was the correct answer. So hopefully this program gives you an opportunity to reflect on exactly how we might start thinking about lists and how we use them in programs. Of course, there's a lot more you can do with lists, and you should check out the lessons and so on and so forth. But this at least is a good taste of how they can be used to store multiple values and how to interact with those values. What we're now going to do is think a little bit about how we can get data from files in Python programs. Once we've got that, we're going to put both of these things together to write our heads up program. Let's get started by showing you a Python program that reads through a file just like I described a little earlier on. The first thing to keep in mind is that we have a constant in this file. Its name is file name, and its value is cswords.txt. That's the name of the file we're going to be reading through. So under the hood, what this looks like is a variable called file name, or a constant variable to be more specific, whose value is the name of the file we're reading through. So what we really need to do now is, given this file name over here, we need to actually open up a cursor or a particular position in the file, starting at the very beginning of the file, and read through it, just like you and I would read a file in real life, and just like Microsoft Word or Spotify or QuickTime are going to go through a file position by position. So that's what this weird looking code over here is doing. I grant you that's probably pretty different to other code you've seen, but I'm going to take you through exactly how it works. The first line over here is with open file name as f. What that basically does is it opens up a particular position in the file. That's what open file name is doing. And it stores it in this f variable over here. Specifically, f stores the position of the very beginning of the file. So what that looks like kind of in our computer is f pointing at the very beginning of the file. So a little earlier on, when I showed you this little red dot that started at the very beginning of the file and then read through each of the lines in the file, what is actually going to be happening in our Python program is that f is going to store where this little red dot is, and f is going to be the thing that moves forward. And that's what's happening in this loop over here, the for line and f loop. What that's going to do is that's going to go through our file line by line and give us back each line. The way that we know how to do that is that we know that lines are separated by these new line characters. So what Python is going to do is it's just going to scan forward until it finds a new line character and give us all the text it's seen so far. It will keep doing that for each line in the program. So specifically, the first time the for loop happens, what's going to happen is that f will move forward on this line. It's going to see this new line character over here, and it's going to stop. And so at the very end, what would happen is that f would point at the beginning of the new line after the first line, and this line variable over here would equal the very first line in our program. So line would point at the string Carol with a \n. Okay, that's super helpful. Let's try that one more time. So we're going to start the for loop again from the beginning. And so this time, f is going to move forward on this line until it gets to the start of the next line. So if we do that, then what's going to happen is f will point at the very beginning of the while loop line, and this variable over here will be replaced by for loop \n, because that's what f scanned the previous time. We'll do that one more time. We'll say, okay, F should move down to the next line of the program. And this string over here, the line variable, should now be equal to while loop. Okay, great. Super exciting. So this is going to keep on happening until we get down to the very bottom of the file. That is the last line in the file. So let's go ahead and do that. F points at the very bottom of the file. That is the line starting random. So this is the very last line of the file. And so what's actually going to happen here is that we'd read that line. So our line would be equal to the string random. And then F would stop pointing over here. So it would point at the very end of the file. And because there isn't a new line to go to, there's no new line character over here, what would happen is the for loop would end. All right, cool. So now that we have a sense of how Python actually reads through files, let me go ahead and run this program and show you how that happens. So again, we've just opening a position in the file. We loop through the file by looking at each line in the file one by one, and then we print it. So let's go ahead and run our program and see what's up. Okay, so we're seeing a bunch of words. Let's scroll up a little bit and keep scrolling, and there we go. So we started with Carol, and then for loop, and then while loop, and then if statement, and then went all the way down to random, which you'll notice is also what happens over here. Random is the last word in the file, and Carol, for loop, while loop, and if statement are the first lines of the file, which is really exciting. But also, here's the deal. There's something a little strange going on here, and that's there's these random blank lines between each word that we print out, which is probably not ideal. But let's talk about why that is. Let's again go back to our little whiteboard over here, and let's talk about what happens in this particular case when F is pointing over here and our line variable is pointing at the string Carol \n. So what's actually going to happen is when we try to print that string over here, what we're actually going to be doing is calling print Carol \n. So the problem is that we're trying to print this new line character over here. And that's a problem because whenever we print, we already get a new line character. For example, if I comment this out and say something like print hello, and then on the next line, print hi, and run this program, you'll notice that we see the text hello and then the text hi right after that, meaning there is an invisible new line character over here, which is meaning that hi gets printed on the next line. But if instead I try to print hello exclamation mark and then a \n manually and try that out, look what happens. So we print hello back, and then we've got a \n, which comes from here. That \n or new line character moves us over here. But then the print statement adds its own new line character as well, meaning that we jump down one more line and see this hi over here. So really, what we want is not to print Carol \n, but rather just to print Carol without the \n. And it turns out there's a really nice way of doing that in Python. It turns out that what we can do is just call the strip function on each line. What that's going to do is that just removes spaces from either side of the line, including new line characters. So what I could say is something like this: print line.strip and run this program. Great. So we get the same output this time, but now they're on consecutive lines. There's no blank lines between them, which is really exciting. So even though we're not done with the heads up program yet, this is a really, really big step, because now for the first time, we have a program that's reading from an external source. This program isn't just creating all of its own variables, it's actually getting variables from outside of the program, from a separate file. And that's a really, really powerful tool to have under our belt. But of course, that's not the program we're trying to write. The program we're trying to write allows us to read all the words and then continuously choose random words from them, which means that we need some way of actually storing the elements from the word. We need some way. Okay, so this is a really huge step in our favor. We now have a program that for the very first time is getting variable values from somewhere else. It's not creating its own values. And that's thrilling. That's a really powerful thing to have under our belt, but that's not the heads up program. So let's talk now about what needs to happen for the heads up program to work. I'm going to comment this out. And then in comments to myself, let's start making notes about what needs to happen. We need to read through the file and get the words. We need to randomly show words to the user. Okay, so with that in mind, let's now talk a little bit about how exactly that's going to work. So the first task over here is reading through the file and getting the words. Immediately when I see something like this, I kind of think, okay, I probably should write a function for this to do this work for me, because it kind of feels like there might be a bunch of stuff going on. So let's go ahead and say something like get words and leave a pass. So what that means is we can now say something like get words down here. We can call the function because we know we're going to need to use it. So let's talk a little bit about how exactly this function should work. I think one reasonable for this function to do is to read through the file and return the words. But now the question becomes, how do we return the words? There's a lot of words and the function can only return one thing. So what we need is a variable that can store a lot of words. Think about how that might work. It may sound familiar. Yep, that's right. We're going to need a list to return. So what we probably want to do is say, okay, let's read through the file and return the words in a list. That's a single thing that can contain a lot of words inside it. And because we know that this function is going to read through the file, we also know that we can immediately include that with, with open file name as F and then for line in F. We also know that at the very bottom, we want to return a variable. Let's say return words in file. And we know that this is a list of all the words. So because we know this is a variable we need to return, we need to create this list somewhere. And I think a reasonable place to create this list is over here, right before the for loop, because now what we can do inside the for loop is append to that list. We could say something like words in file.append. And what that's going to do is that's going to take whatever we place the parentheses over here, and it's going to actually put it at the very end of the list. Because we're declining the list outside of the for loop, it's going to persist throughout the for loop, and we're not going to wipe it out every time the for loop begins. So what we probably want to do is, rather than printing each line, we probably want to store it in the list, right? Each line in this file is a particular word to guess. It's Carol, or for loop, or while loop, or if statement, and so on and so forth. And so what we probably want to say is, okay, line dot strip in there. Remember, we include the dot strip because we don't want the new line character. That's only for us to know what separates the particular lines. Okay, so now we have get words, and because get words returns a list, as we see over here, it's probably a good idea to store that. So say something like words is equal to get words. Now that we've done that, it might be worth just sanity checking that we got this program right. So print the list and see what's going on. Let's go ahead and try that. Python 3 heads up.py, run that, and great, that looks like a list. That starts with Carol and then has for loop and then while loop and then if statement, and goes all the way down to random over here, which is exactly what we need. Which means now what we want to do is play the game. We want to randomly show words to the user. So let's go ahead and do that. Let's say something like play game and pass in the words as a parameter. And now we have to define that function. So let's go ahead and say def play game over here, pass in words. And for now, let's just say pass. And let's quickly describe to ourselves what's going to happen over here. Repeatedly show the user a random word and wait for them to enter. Okay, cool. So let's go ahead and start. Let's say something like, okay, we need to repeatedly do something over here, which means we probably need a loop. And here's where kind of one of the fun decisions happens because we're making a game. We can decide what that loop should be. So for example, I think maybe this should just keep on going until the user ends, meaning I probably want like a while true loop over here or something like that. Now, that's kind of one way of solving this, but you might say, you know what, it shouldn't be a while true loop. I don't want this game to continuously go. And what I might want instead is to just say, hey, the user gets 10 turns or something like that, in which case it might make more sense to use a for I in range 10. So I'm going to go with the while loop over here just because I think that this game is most fun when you just keep on playing until you get sick of it. But if you feel like maybe there should be turns instead, a for loop might be the way to go instead. Okay, so now that we've got that, what we want to do is pick a random word in here and then show it to the user and wait for them to press enter. Let's start by picking a random word, but because that feels like maybe a little tricky, what I'll do for now is just say, okay, word is equal to Python. Just create a word variable that eventually will be a random word, but for now is just going to be Python so we can test the next thing. So here's something kind of subtle. All we want is to show the user a word or a piece of text and have them press enter. And it turns out we have a function that can do that for us. We've got the input function into which we can pass word. So remember, what the input function does is it shows the user some text, maybe waits for them to type something and presses enter. But we don't need to do any of that, right? We just need for them to press enter, which the input function will do. So if we run our program now, it says the word Python and then just stops. It waits for me to press enter, which I'm now going to do. And when it does that, it shows me the next word, which is still Python. And then I press it one more time and another time and another time and another time and another time, and it just keeps on going. So input feels like a really good tool for this to be done. Now, all that remains is for us to just pick a random word. It turns out that there's just a function that can do that for us. It's called random.choice. And the way it works is we can pass in a list as a parameter to this function. So the words list over here. And what it's going to do is it's just going to return a random element from that list every time. So previously, we've talked about other random functions. We've talked, for example, about random.randint, which returns a random integer in a particular range. What random.choice does is it returns a random element from a list. So if we go ahead and run this program now, we see that we get a random word from the list, diagnostic. Let me actually pull this up so I can show you that all of these words are from here. So there's diagnostic. If I press enter again, we get turn right, which is right up there. And then we get Python, which I'm sure is somewhere in this file. Yep, there it is. And then let's press one more time. We get Chris Speech. Again, as you saw when Patricia and I played the game, that's in the file. So great, we now have a working program. You can press Control-C to end the loop, and that works. So we now have a program that reads through a file and shows you random words, which is exactly what we need for the Heads Up game. What I think is really cool about a program like this is it's not that long. It's maybe in total 20 lines of code or something like that. But again, there's just so much going on in this. We need to read through a file. We need to store stuff in a list. We need to retrieve random elements from the list. And so it's a really nice intersection of everything we talked about earlier on, with how files are represented and how we read through them, as well as how lists can be used to store a ton of different elements. So now what I want to do is quickly talk about some other cases where tools like this are incredibly helpful. Let's go. All right, so I want to talk about the last problem in this week's section, and it's really not so much a problem as it is a challenge to you. One of the most exciting things about being a programmer today is just the incredible amount of data you have access to with the ability to use programming as a tool to tell stories about that data. For example, for the last year and a half, countries all over the world have been collecting data on their COVID-19 cases, how many cases there have been, how many deaths there have been, how many recoveries there have been, and so on and so forth. And what's really exciting is that they've been making a lot of this data public, meaning that you and I, as programmers, can look at this data and do things with it. So over here in the section problem, if you open the countries directory, what you actually see is a file for every single country on the planet. Let me go ahead and open Italy's file. And you'll notice that Italy's file is basically just a bunch of numbers, as are the files of any other country. They're all just a list of numbers. So let me quickly take you through exactly what these numbers mean. Well, each number basically represents the number of total confirmed cases in that country on a particular day. The first row is always January 22nd, 2020, and it just keeps going up by 1 day. So this is January 23rd, 2020, January 24th, 2020, and so on and so forth. And if we scroll all the way down to the bottom, this corresponds to today's date, which is May 12th, 2021. So that's kind of what this is supposed to do. Now, I want to be clear on what exactly these numbers mean. All of these zeros over here mean that up until this day, there were no cases in Italy. On this day, which I believe corresponds to January 31st, 2 people got COVID-19, and so there were 2 cases in the country. Then no one got COVID on the next day, or 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 the next day. And then the day after that, 1 person got COVID, increasing the total number of cases to 3. So the key idea over here is that these numbers are always going up because they represent how many people had COVID in total, not how many new people had COVID each day. So really, that's all there is. The idea here, though, is that there's kind of a story you can tell. Let me show you one story that I think is sort of fascinating over here. And that's that just how quickly the cases accelerated in Italy. For a few days, about a week and a half, there were no cases. And then for about a week, there were 2 cases, and then 3 cases. And then immediately after that, it jumped to 20, and then 62, and then 155, and then soon to 1,000, and then soon to tens of thousands and hundreds of thousands, and so on and so forth. So our task as programmers is to use Python as a tool to try and tell a story with this data. And really there's 3 steps you might take here, and we've outlined some of them over there. So let me take you through what those steps are. So the first step is to just load all the values from the file into a list of integers. Now over here, as an example, I showed you Italy, but like I said, pretty much any country on the planet, including most likely the country you're currently in, will have a file over here. For example, I'm in the United States, and let's see, yeah, there's the US file. So here's the US, and it just keeps going up, and these are the numbers for the US. So go ahead and choose to analyze whichever country you'd like, but really the big idea over here is that you want to be able to load the data that's in a file into a list on your program. And the reason you want to do that is because once you've got this data in a Python variable, you can start to do things like loop over the list, or index into the list, or slice out smaller lists from that list. These are all incredibly powerful things to be able to do, which you can't do with the data just in a file. Once you've got this data in a list or some sort of data structure that you think would be helpful, one thing you could do is just count the number of non-zero values in the file. So if we open up some random countries, again, let's say Antigua and Barbuda, you'll notice that there's a lot of zeros. And then on day 52, the first COVID case happened, which meant that every day after that had COVID cases in it. And so if you count those number of days with COVID cases, you'll know how long COVID has actually been a problem in that particular country. And that's kind of an interesting insight to have, and something that you've probably maybe tracked for your own country. Another thing you might want to do is to create a list which stores how many new cases there were each day. So what that would look like is for Antigua and Barbuda, for example, notice that between day 474 and 475, 6 people got COVID. Now, this is probably the metric that most people have been looking at for COVID cases wherever they were, how many new people were getting it each day. Having that statistic allows you to track whether or not cases are generally increasing, meaning that you need to take further measures to reduce the spread, or whether cases are decreasing, meaning whatever measures you are taking seem to be working. So here's the deal though. I'm not going to work through these problems with you because they're not solved problems. There are many, many different ways of approaching them, many, many different ways of extracting meaning from them. And really what we want you to do is think critically about what questions you would like to answer from this data and how you can use your Python skills to answer those questions. We've given you a few examples of questions that actual scientists all over the world are working on. For example, how can you tell whether the country has turned the tide on the current wave of COVID-19? Is it possible to look at the graph of cases and say, this country is now past the peak? can we predict the future number of cases based on like the last week or two of trends? If there have been an increasing number of people each day with COVID, can you tell how many people are going to have COVID tomorrow? Another thing is, can you try finding data outside of this, Googling it and doing your own research to find information that may correlate to the data over here, noticing, for example, events in your country that maybe led to spreading, or policies your country enacted that maybe led to COVID cases decreasing. These are all fascinating things to be able to do. And like I said, there are no correct answers. What's exciting about something like this is that you get to decide both the question as well as your approach to the solution. And really deciding both those things makes the process of coming and arriving at an answer even more thrilling. Now, if you'd like, you could work on something like this for your final project. The data over here is actually all accurate data. We got it from some studies done by Johns Hopkins University, who update their own data every single day. So this is actual COVID data, and you're welcome to do something with this. There's a lot of really, really cool things you can do. And that brings this section to an end, as well as all of our Code in Place sections. It's been an honor and a pleasure to guide you on your journey, but what I really want to do here is celebrate how far you've come. You started just having to learn how to define new instructions for Carol, teaching it to turn right or repair a column or find the midpoint of a wall. And now you're able to write programs that can read data in from files and do something like build a game from that data, or start doing data analysis on that data. That's really, really, really exciting, and something that you should be really, really proud of yourselves for. We're so excited to see what you do next with your programming experience. But until then, we encourage you to keep coding, both in and out of place, and see what magic you can bring into the world. Bye, everyone.